What's up, math brainiacs? Welcome back to Arithmophilia. Don't forget to subscribe. For today's video, we are going to discuss the concept of remainder theorem and factor theorem. Specifically, its definition, proof and applications. But before that, let us be guided of objectives that we need to achieve at the end of this video tutorial. First, define remainder theorem and factor theorem. Second, prove remainder theorem and factor theorem. And lastly, find remainder using remainder theorem and factor theorem. Without further ado, let's now start our discussion, starting with the definition of remainder theorem. Remainder theorem is another method in finding the remainder. This theorem tells that if the polynomial p of x is divided by the quantity of x minus r, the remainder r is a constant and is equal to p of r. So, how can we use the remainder theorem? We will simply change the sign of r in the quantity of x minus r, and substitute into the given polynomial p of x. Before going to some examples, let us show first the proof for remainder theorem. In any division problem, if we divide the dividend by the divisor, it is equal to the quotient. If there is a remainder, we will add the remainder over the divisor. In symbols, the dividend is denoted by p of x, the divisor is denoted by x minus r. The quotient is denoted by q of x, and the remainder is denoted by r. Then we have p of x over x minus r equals to q of x plus r over x minus r. Let us now multiply both sides of this equation by x minus r. On the left side, we have x minus r times p of x over x minus r is equal to p of x. On the right side, q of x times x minus r plus r times x minus r over x minus r, which is equal to r. We now have p of x equals q of x times x minus r plus r. Let us now evaluate p of x for r, by substituting r to x in this equation. P of x becomes p of r, q of x becomes q of r. X minus r becomes r minus r plus r. Let us now simplify. P of r is equal to q of r times 0, as the difference of r minus r plus r. And we have p of r is equal to 0 plus r. Therefore, the remainder is equal to p of r. And this is the proof of remainder theorem. Let us now consider this example to better understand the concept of remainder theorem. Find the remainder when p of x is equal to x cubed minus 2x squared minus 5x minus 8 divided by x minus 2. Since our constant in our divisor is negative 2, we are going to use the opposite sign of our constant, which is positive 2. Let us substitute this to every variable x in the dividend. We now have p of 2 is equal to 2 cubed minus 2 times 2 squared minus 5 times 2 minus 8. Simplifying this, we can get p of 2 equals 8 minus 8 minus 10 minus 8. P of 2 is equal to negative 18. Therefore, the remainder when p of x is equal to x cubed minus 2x squared minus 5x minus 8 divided by x minus 2 is negative 18. Am I understood? If yes, let us now discuss factor theorem. Factor theorem states that, if we divide a polynomial p of x by x minus r, and x minus r is a factor of the polynomial p of x, then the remainder of that division is simply equal to 0. Thus, according to this theorem, if the remainder of a division like those described above equals 0, x minus r must be a factor. If the remainder of such a division is not 0, then x minus r is not a factor. Before going to some examples, let us show first the proof for the factor theorem. Using the division algorithm, p of x equals to q of x times the of quantity x minus r plus r. Where p of x is the dividend, q of x is the quotient, x minus r is the divisor, and r is the remainder. By the remainder theorem, r is equal to p of r. Let us substitute p of r to the remainder in this equation. We now have p of x equals to q of x times quantity x minus r plus p of r. Since p of r is equal to 0, according to factor theorem, let us substitute 0 to our p of r in this equation. We now have p of x equals to q of x times quantity x minus r plus 0. Therefore, as a simplified form, we finally have p of x is equal to q of x times quantity x minus r. This is the proof of the factor theorem. Example number 1. Show that x minus 2 is a factor of p of x equals x cubed minus 5x squared plus 6x. In this example, x minus 2 is in the form of x minus r, where r is equal to 2. Let us substitute this to every variable x in the dividend. We now have p of 2 is equal to 2 cubed minus 5 times 2 squared plus 6 times 2. Simplifying this, we get p of 2 is equal to 8 from 2 cubed minus 20, coming from the product of 5 and 4, plus 12, as the product of 6 and 2. We now have p of 2 is equal to 8 minus 20 plus 12. Finally, our p of 2 is now equal to 0. Since p of 2 is equal to 0, then x minus 2 is a factor of p of x equals x cubed minus 5x squared plus 6x. Alright, did you get the procedure, brainiacs? Now, let us have another activity for you to practice your newly learned skills on remainder theorem and factor theorem. Try doing this task again on your own in your notebook. Perform the activity entitled, Come and Challenge Me. Part 1. Use the remainder theorem to find the remainder, r. Part 2. Use the factor theorem to determine whether or not the first polynomial is a factor of the second. Good luck, brainiacs. Before ending this lesson, please take note of this. For you to measure your previously learned understanding on remainder theorem and factor theorem, you can answer the 10-item test that I have prepared for you on my quizzes.com account. How? Just search or click the link in the video description below. Enjoy! This ends our lesson for today. Thank you, brainiacs. See you on our next episode.